And that is indeed good news. It is very good news that the world is now looking at the need to put back on the agenda nuclear non-proliferation. It's very good news that it's being done in a multilateral context, and not only in the sense of finger-pointing and saying, Iran, you're a problem. North Korea, you're a problem. But the US and Russia having all these weapons doesn't bother anyone because everyone knows we don't plan to use them, except maybe later. We've really got to make sure, and I know your movement will, push ahead to make sure we know that the nuclear non-proliferation agenda takes hold, sinks in, and moves into the next round of treaties, and that we don't allow violators off the hook. I'm going to come back to Canada's role in all this in a minute because we don't have a good record on this. The next thing we need to look, so that could be done. A lot of it is public education. A lot of it is maintaining the pressure at the multilateral level. But at least, as I said, we have a lot of investment in a military-industrial complex, but we don't have a consumer demand for nuclear weapons. I mean, it's obvious, but it's worth saying. It makes life a lot easier for us in pursuing a non-nuclear world that it's not part of our day-to-day lives. Which brings me to the climate crisis. Because the use of fossil fuels is part of our day-to-day lives. And there still remains consumer demand for the climate crisis equivalent of a nuclear weapon in your garage. Because the climate crisis poses just as grave risks to the planet as a nuclear exchange. You don't often, yes it does. I'm sorry, let me explain runaway global warming to you, okay? If we don't ensure that greenhouse gases stop their rise by 2016 and start coming down after that, this is based on information from the Intergovernmental Panel on Climate Change and the International Energy Agency. If we don't ensure that the rise in greenhouse gases, they're continuing to rise as we speak, we don't ensure that they stop their rise by 2016 globally and at least start coming down from there, we will have committed the atmosphere within a century to an increase in global average temperatures such that it will not be possible to reverse the rise in greenhouse gases, and we will have triggered something that scientists call runaway global warming. Now, let me get back to some basics on the science. The average planetary temperature, a change of 1 or 2 degrees may not seem like much. So let's just get a little context. The difference in temperature between planet Earth today and in global average temperature, planet Earth at the last ice age, difference is 5 degrees Celsius. Global average temperature changes on the order of 1 or 2 degrees is huge. 5 degrees, again, that's the difference in global average temperatures between the hospitable, temperate climate that we largely have on planet Earth today and an ice age. So we've already committed, this is the scientific language, we talk about having committed the atmosphere. There are long lag times with the climate issue. So as we add more greenhouse gases, we not only increase, say, the tons of pollution into the atmosphere, but because there is a carbon cycle, and because green leafy things and oceans absorb carbon and act as a carbon sink, that's the term, or a reservoir of carbon, they sequester carbon, pull it out of the atmosphere and release oxygen. Over time, as we increased our pollution, we were okay because the capacity of the sinks kept our global climate pretty much the way it had been, and also allowed the average, the concentration in the atmosphere, which is different from a pollution in tons, just to get you in the same frame of reference here. The concentration of carbon dioxide in the atmosphere is expressed in parts per million. So that's not an annual thing. That's a statement of the chemistry of the atmosphere. So before the Industrial Revolution, there was never a time that when humans were living on the Earth anyway, there's never been a time when the amount of carbon dioxide in our atmosphere exceeded 280 parts per million. Now, that's a pretty small amount of carbon dioxide, so let's just think about that. Parts per million If you're used to dealing with toxic chemicals and fighting the chemical companies the way I did, that's the kind of concentration where they say, don't worry, you could drink that. That's a few drops in a swimming pool. That's nothing at all. 280 parts per million is not a lot of carbon dioxide. But without it, this planet would be far too cold to sustain life at all, because the natural greenhouse effect, like the natural ozone layer, sustains life on Earth and protects us here. Without the natural greenhouse effect, this planet would be too cold to sustain life at all, and this vanishingly small amount of carbon dioxide, 280 parts per million, is what makes the difference between a planet that has no life and a planet that does. So we know by direct measurement of the chemistry of our atmosphere how much CO2 has been in our atmosphere going back a very, very long period of time. Now, if you're still with me, you'll be wondering, how do we know by direct measurement anything about the atmospheric chemistry going back a long period of time? And it's because of some very genius science. They do ice core drilling in Antarctica. And the Antarctic ice cores go back a very long time and provide an actual record of the chemistry of the atmosphere, because they can measure exactly when that ice formed, carbon dating. They can tell this is a 1,000-year-old piece of ice, 10,000-year-old piece of ice. They've done testing going back 1,000,000 years. And in every piece of ice, guess what? It doesn't form solid. There's always air bubbles. So every air bubble is a time capsule into the atmosphere and the chemistry of the atmosphere millennia ago. So that's how we know with absolute certainty that at no time when human beings have lived on this planet have we ever had carbon dioxide exceed 280 parts per million. And due to human activity and the burning of fossil fuels and the destruction of our forests, we're now at about 390 parts per million. In scientific terms, they'll say that commits the planet, that commits the atmosphere to at least 1 degree increased warming in global average temperatures above what we had before the Industrial Revolution. Back to why we have to ensure that greenhouse gas levels stop rising by 2016. If they don't, we go right past 2 degrees Celsius average global temperature increase. We hit 3 degrees Celsius global average temperature increase. If you've read George Monbiot's book, Heat, you've read a good explanation of this already. But what goes to 3 automatically goes to 4. If it goes to 4, it automatically goes to 5. If it goes to 5, it automatically goes to 6. If it goes to 6, it goes to 7. No one can imagine how anything like our current human civilization could stand that level of dramatic change on the planet. We would trigger events that are right now still possible, but only remotely possible. Let's hope they never happen. Things like stalling the Gulf Stream, which would happen because as the melting ice from the Arctic comes down into the Gulf Stream, it's fresh water. The ice in our Arctic, North Pole ice, it's all fresh. So when it comes down, it floats on the surface, it depresses the Gulf Stream. The Gulf Stream's already 30% slower than it was 20 years ago. Okay? So the other big catastrophic trigger events would be, for instance, losing the Greenland ice sheet. You've probably read it's already melting a lot. It seems to be having a lot of movement under its surface. If we lose the Greenland ice sheet, the Intergovernmental Panel on Climate Change projections for sea level rise go from 1 meter sea level rise to 4 to 5 meter sea level rise. If we lose the Western Antarctic ice sheet, we go to 4 to 5 meter sea level rise as well. If we lose both, well, that would be a 10 meter sea level rise. Begin to imagine what happens in a world where an event like Hurricane Katrina hits different parts of the world all at once and over and over and over again. And try to imagine the capacity of human ingenuity, the money, the rescue attempts. What happens with the environmental refugees? If we were, for instance, to lose the Gulf Stream, this is a scenario exercise that, believe it or not, comes from the Pentagon. And they did it in the Bush administration but didn't reveal it. Now lately, the Obama administration has begun to talk about it a lot and say out loud that the climate crisis is a far bigger threat to security than terrorism.